Today we're going to talk about tangent lines. As a reminder, I'm just going to draw right above. What is a tangent line? Not tangent as in trig. What's a tangent line? And it only intersects one time. And that point where it intersects is called the point of tangency. All right, perfect. So just as a reminder, tangent line, it's outside the circle, but it intersects the circle one time. Now, we learned last week on Wednesday when we did our vocabulary that if a line is tangent to a circle, then the line is perpendicular. And I don't want you to write circle. Can you scratch that out? I want you to write to the radius at the point of tangency. A line is perpendicular to the radius at a point of tangency. So up here, if I were to draw the radius and connect it to my point of tangency, this creates a 90-degree angle. Every time. A tangent line and a radius create a 90-degree angle. You can close your computers because you should not be on them, please, or like put them at a 45-degree angle. All right, so let's look at example 1. It says AB is tangent to C at point B. What can I add to my picture? Let's add a right angle at B. It also says AC, if AC is 25, so AC is 25, how can I find the radius? How do I find this radius right here? Pythagorean theorem. Do you now see it though? Yeah, I see it. C squared equals A squared plus B squared. Now, what do I have? 625. But what is that? 25 squared. 25 is my hypotenuse. That's my C. Please make sure you're paying attention to where things are. All right, and then I get 625 equals 225 plus r squared. I'm going to subtract 225 from both sides. What do I get? 400 equals r squared. And does that square root pretty? Yes. So what? So my 20 is my radius. That's the answer. Does that make sense? Okay. Next question. It says ML and MN are tangent to circle O. What can I add here? Right degree angles at L and N. There's a 90-degree angle at L and at N. How do I find the value of X?
180 minus 117. We're not cosine. 180 plus 117. We subtract that.
What shape is this? It's a quadrilateral. And because it's a quadrilateral, not a parallelogram, it equals 360. Now hold on. Y'all are like opposite angles are supplementary. That's not always true unless it's a parallelogram. But you're right. I agree. But I'm just going to go with it. So do y'all agree 90 plus 117 plus 90 is what?
I'm just wondering somebody. 90 plus 90 plus
297. What do I do with that?
You minus it from 360.
Subtract it from 360.
And you get 63.
And I get 63 degrees. X is 63 degrees.
Wait, what?
Add them together and subtract from 360 because it's a quadrilateral. I know it. All of them together equal 360 degrees. Okay? Yes.
Because we already know that the 90 is 360, can we just do 180 minus 117?
Correct. But I just want to reiterate that that's not always going to be true. It just happens to be true because these are both 90. Does that make sense? Okay. Alright, if you can open up your notes, has everybody got both of those down? Okay. The next question, which you're going to see on your homework, says, is AB tangent to C at point B? How do I know if something is tangent to a circle? It would have to be 90 degrees with the radius. Is this 90 degrees? How do I know? Can't just assume. Yeah. But I don't know. The question is, I don't know if this line is tangent. Over here, I told you that they were tangent. So that's why you could do the 90. Over here, I'm saying I don't know. Somebody just said I could do what? I could do Pythagorean theorem and see if it equals 90. Because remember, if c squared equals a squared plus b squared, then it's a right triangle. So what's my c here? 52 squared. Does 52 squared equal 44 squared? I cannot write. Plus 20 squared.
No.
Well, what's 52 squared?
I have no idea. 2,704.
2,704. And what is 44 squared plus 20 squared?
1,936 plus 2,336.
Yeah. Are those equal?
No.
No. Is this a right triangle?
No.
No, they're not equal. What kind of triangle is this? It is an obtuse triangle. So is this tangent? No. AB is not tangent because it's not a right angle. AB is not tangent because angle B is not a right angle. Does that make sense? Do Pythagorean theorem. If they equal, it's a right triangle, you're good. Alright. I'll give you a minute to write that down. And then we're going to talk about this next question, which is a little bit weird. Looks like what? No, it's pulleys. Like a pulley? Like a rope with a pulley? Two wheels and the rope goes through it? Okay? So it says a belt fits tightly, like a bicycle. Think of a bicycle. A belt fits tight around two circular pulleys. Find the distance between the center of these pulleys. So if you need to, use your badge, draw a straight line. Nope.
Where do you get that number?
Where does one get that from?
No, because it said 35 degrees of angle.
No 35 degrees anywhere.
Oh, yeah. Nowhere on the
That's
paper.
35
Inches.
Oh, yeah. 35.
Okay. So, I'm going to guide you on how to do this. I need everybody to look up and watch me first, please. Do you agree that this right here is 8 inches? And look up, and this is 35. Do you agree, look up, I could make a rectangle if I go 8 inches on this side and 35 inches, goodness gracious, this way. Do y'all agree I just now created a rectangle? Everybody agree with that? So I have a rectangle that is gray right here. What is this right here? Why 6? 14 minus 8. Do y'all agree that is 6? What is this right here? A 90 degree angle. Do y'all agree? And then what about right here? What is this? Do y'all agree that's 35 like above? How can I find the distance between the pulleys? Pythagorean theorem. So sure, but like what numbers would you have used?
I would use 35.
and 8, and that's wrong. Because look at your blue triangle. 35 and 6. So do you see how if you use those numbers right off the bat, you got it wrong? Okay. So I'm looking for my hypotenuse. So what is 35 squared plus 6 squared? And when I get this, does it square root pretty? No, it doesn't. Last period we sat there and searched. I divided by 144, I divided by 121, I divided by 100, I divided by 81, all the numbers, and nothing worked. So then I just Googled, is 1,261 prime? And it said no. The only numbers it multiplies by are 97 and 13, which are prime. So we are just going to leave it like this. So C equals the square root of 1261 inches. Or we could say, what's the square root of 1,261? Or we could say 35.51 inches. This doesn't really give us any guidance on rounding or exact answer. So I just want to remind you, up top is the exact. If it says round, you do the bottom one. Okay? Questions? Okay. The next property, I love this property. I don't know why, it reminds me of a puzzle. Says that two segments tangent to a circle from a point outside the circle are congruent segments if they intersect. So, look up. If all of these segments are tangent, do you agree these two tangents intersect at G? So this is congruent to that. Do you agree these intersect at E? So this one is congruent to this one. These intersect at C. This is congruent to this. And right here, 1, 2, 3, 4, 1, 2, 3, 4. Now these may or may not be congruent to each other, like this one versus this one. But these two are congruent, these two are congruent, vice versa. So now this tells me JG is 7. Label that. GE is 9. Label that. And CE is 8. Label that. And what do I want you to find? FE, JC, and the perimeter. I always think of these as a puzzle. Kind of like Sudoku, but not at all. What do we know?
CD equals 5.
What? C what?
CD equals 3.
CD equals 3. Why? Because if that's 8 and that's 5, what's the left side? 3. Okay, what else do I know? D, what? Say it again?
FE is 5.
Why is FE 5?
Because it's congruent.
Because these are congruent, so that's 5.
9 minus 5 to find GF.
So then, if I know the whole thing's 9, that's 5. What's GF?
4. And 4 is also congruent to HG. And then you do 7 minus 4 to find.
You see how I mean like a puzzle? Like once you got it, you can keep going. So again, 9 minus 5 is 4. These are the same, so they're both 4. 7 minus 4 is? These are the same, so it's both 3. All right, what else?
I used to add all this.
CD is congruent to BC.
CD is congruent to BC, so they're also 3. So what is JC? So FE was 5. Do we have any units? No units. JC is? And how do I find the perimeter? So 6 plus 7 plus 9 plus 8 is 30.
See, miss, I told you. Miss, can we like only have those?
You like those, right?
I don't like those.
Not too bad? Okay.
Is that on my homework?
Uh-huh. Okay. I'm going to slide over and do this next one right here. Number 7, and then I'll do number 6 last. Number 7, hey, y'all look up. Can y'all see this line right here next to the circle? It's kind of like hard to see, but you can see the arrow. Can y'all use your pencil and bold that a little bit? It's hard to see. If you don't know you're looking for it, it's a little hard to realize it's there. Does everybody see that now?
Yeah.
Logan, you with me? Will, you with me? I see Will's pencil moving. Brandon, can you get Logan with me? Just like elbow him. Thank you. Okay. How do I find the R of this circle? What's R stand for? How do you find the radius of the circle? Literally count. 1, 2, 3, 4. It's a graph. Count it. What is the point of tangency?
1.
Do y'all agree that line intersects my circle at 1, 1? Y'all, if I'm asking for a point, you need parentheses. It's a coordinate. Okay. Equation of the tangent line. Before I get into that, everybody look up. Do you remember your algebra teacher teaching you Hoy and Vux?
I haven't used it.
Okay, if you didn't, just write that down for me just to have it. Hoy and Vux. Hoy stands for horizontal lines have 0 slope and are y equals. Vux stands for vertical lines have undefined slope and are x equals. Look at my green line. Is it a vertical line or a horizontal line? You are going to use Vux, which means the equation of this line is going to be what?
Y equals.
Vux is, it will be x equals. Also, you can always tell. You can always tell, does it cross the x or the y axis?
Cross the intersection.
Where?
1.
That's your equation. X equals 1. So if you get confused or you don't remember Hoy-Vux, just look, is it crossing the x or the y? That's your thing. Okay? Any questions about that?
No.
Okay, last problem. I'm going to wait. I see people writing, so I'll wait for y'all.
Just can we try it?
We'll do it together real quick. Is anybody missing today? No. Where it crosses the x-axis. Yep, so it crosses the x-axis right here at 1. That's what, yep. All right, last problem, please look up. We have, the last theorem says, the line through an external point and the center of a circle bisects the angles formed by the 2 tangent segments. That is a really fancy way, get your badge, to say if you connect A and C, this line right here bisects that angle.
So wouldn't the other angle be 80 again? So the other side?
The other side would be 80 as well, yes. No degrees, sorry. The other side would be 80. And it says the radius is 39. Which means what? What is 39? CD is 39 as well as BC. And this question wants you to find AB, CB, AC, and angle ABC. I'm going to give you 1 minute. I would like you to try doing each of those. Go.
Hey, Mrs. It's
They
a
could
nice
work.
number.
All right. Look up real quick. AB. What's AB?
80.
80. We have no units, right? Okay. CB. What's CB?
39.
39. How do I find AC? Okay, why can I do Pythagorean theorem? Right now, my picture does not tell me I can do it.
Because this is because ABC is 99.
ABC is 90 degrees.
Then it bisects.
So because it's 90 degrees, I can do Pythagorean theorem. C squared equals A squared plus B squared. I'm running out of ink over here. So that's my hypotenuse. So 80 squared plus 39 squared. Is that a pretty number?
Yeah.
What do I get when I put that in the calculator?
89.
Well, the whole thing is what?
7921.
And when you square root it, you get what?
89.
There you go.
How's ABCD? Oh, I just added them all up. That's how you answer it.
Yeah. Real quick, what if I wanted to know BAC, angle BAC?
I don't know. Wait, you can do opposite over adjacent.
You could do opposite over adjacent, and you would have to do inverse tan SOHCAHTOA. Could I ask you to do that? I could. I should have on this, but just saying, that's how you do it. All right. Before I let you go, because you're going to have 10 minutes to start your homework, two things. Number one, this is going to be glued in onto page 64 in your notebook. Page 64 in your notebook. Hold on, pause. Second thing, I want everybody to look at number 3 on their homework. Look at number 3 on your homework. How do I find QT?
By looking for Cooper?
That was cute. As cute as that was, how do I find the cutie on my paper?
By drawing Cooper?
Say again. Pythagorean theorem. Now look, hold on. Shh. Pythagorean theorem is great and all. However, all I have is 12. The radius is what?
5. So QR is 5.
So QR is also 5. Then do Pythagorean theorem. All right, just wanted to make sure y'all were clear on that. All right, you should be able to do the rest of this. Glue this onto page 64, and this is due when you walk in tomorrow.